Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, good day everyone. In this video, I would like to explain what we call as a stiffness method. Okay, analysis of indeterminate structures using stiffness method. Okay, stiffness method is actually the second topic of under CS 521 indeterminate structure. Okay, this is the second topic. We will analyze indeterminate structure using stiffness method. So the structure that we are going to analyze in this chapter, okay, start from truss analysis and then followed by beam, and final one is frame. Okay, there are three types of indeterminate structures that we are going to analyze, okay, using stiffness method. Okay, stiffness method is basically come from what we call as matrix method. Okay, matrix method means that you are going to analyze something new. Okay, of course the output is the same because this is analysis, and in analysis we are going to analyze reaction, internal forces, and displacement. Okay, reaction, internal forces, and displacement. But this is actually the new topic where you are going to analyze the reaction, the member forces, okay, intrust member forces, okay, internal forces, as well as displacement, okay, using what we call as matrix method. Okay, so this is also called as stiffness matrix method. Okay, stiffness matrix method. This is the new method where in order to solve for the unknown, okay, for the unknown you will be using the formula. Okay, formula. Okay, you don't need to calculate to apply equilibrium equation to determine reaction anymore, because we will solve the output using matrix. Okay, matrix concept. Okay, means that you have to know how to understand matrix. Okay, matrix concept, and we will analyze, okay, all the values, including displacement and forces. Okay, using matrix. Okay, using matrix. To be specific, is matrix multiplication. Okay, matrix. So this is actually the word stiffness is actually the word stiffness is actually the opposite with flexible. Okay, the first topic is flexibility method, come from the flexible, and actually flexible, the behavior between flexible and stiffness is actually opposite condition. Okay, so in analysis of indeterminate structures using stiffness method, we will analyze first, okay, the truss. Okay, the truss. Okay, this is frame. This is frame. Wait. I need to open the truss. Okay, the truss node. Okay, this is the truss. Okay, so in the textbook, stiffness method has been divided into three main chapter. Chapter number 14 focuses on truss analysis, and then chapter number 15 is for analysis of beam, and chapter number 16 is for frame. Okay, there are three chapters. So start with truss analysis. And if we compare between these three structures, start from truss, and then beam, and then frame. So the level of difficulty, of course, the truss will be the easiest. Okay, the easiest one compared to frame. So beam at the middle. Okay, so in this introduction, I will explain based on the textbook. Okay, the textbook I use here is Hibler textbook. Okay, so let's do it together now. Okay, truss analysis using stiffness method. Okay, let's look at the outcome in this chapter. You will learn the basic fundamental of a stiffness method. Okay, the stiffness method. This is the stiffness method, and then the method will then be expanded to include space truss analysis, beam frame. Will be discussed in the next chapter. Okay, so next. Okay, let's see the fundamental of stiffness method. Okay, there are essentially two ways in which structure can be analysed using matrix method. The stiffness method, okay, tengok kat sini carefully because it will explain, okay, actually the importance or the advantages of using stiffness method, okay, compared to the previous chapter, okay, the previous method that we have learned previously, okay. The stiffness method to be used in this and the following chapter is what we call as displacement. So displacement method. Okay, it is also known as displacement method. Kalau for flexibility method, okay, we also flexibility method is force method. Do you remember? Flexibility method is also known as force method. Force method. Flexibility method. Because the name of the topic, okay, used to represent flexibility method in the textbook is actually called as force method. Okay, flexibility method is also known as force method. Why it is force method? Because the output that the redundant, because of the redundant. Because of the redundant, the output means that we will solve the compatibility equation to determine redundant. So what is actually redundant? Redundant is actually force, okay, force value. So that is why we also call flexibility method as force method. But in stiffness method, okay, in flexibility method, it is also called as force method because of the redundant. Redundant is the output, okay, is the value that we analyze. Okay, we are going to analyze in if we analyze structures using flexibility method. Okay, so it is also known as force method. Okay, in stiffness method, we can also we can also call the stiffness method as displacement method. So stiffness method is also known as displacement method. Okay, force method is actually stiffness method, flexibility method is force method. So force method means that we determine force as the output, okay, of analysis, force. Okay, and in stiffness method, it is also called as displacement method. Displacement method means that we are going to determine displacement by solving the equation. Okay, solving the equations. Okay, let me write it like this. Okay, in flexibility method, okay, in flexibility method, we also call flexibility method as force method. Force method. Okay, why we call it as force method? Because of the redundant. Because of the redundant. Redundant is the output. Redundant is the output. Redundant is the output. And to solve for the redundant, we solve the flexibility equation. Okay, to have the redundant, we need to solve the flexibility equation, or this is also called as compatibility equation. Okay, this is actually what you have learned in chapter number 1. Okay, flexibility method we use to analyze indeterminate structures. In flexibility method, we also call it as force method. And in force method, okay, the redundant is the output, redundant is force, that is why we call it as force method. How to determine the force or the redundant? Okay, by solving flexibility equation. By solving flexibility equation, and flexibility equation is also called as compatibility equation. Okay, so while in stiffness method, okay, we also call stiffness method as displacement. Okay, displacement method. Okay, why we call it as displacement? Okay, because the displacement is the output. Okay, displacement is the output. And how to determine the output? How to determine the output? We determine the output means that we determine displacement using stiffness equation. Stiffness equation. And stiffness equation is also called as force displacement equation. Okay, this is actually the difference between flexibility method and stiffness method. Flexibility method and stiffness method. Okay, so we go back to this. A force method called the flexibility method, okay, can also be used to analyze how structures. Okay, however, this method will not presented in this text. There are several reasons for this. Okay, several reasons for this. Most important, stiffness method can be used. Okay, this is actually the advantages of stiffness method. Okay, most important, the stiffness method can be used to analyze both determinate and indeterminate structures. Okay, most important, the stiffness method can be used to calculate or to analyze both determinate and indeterminate structures. Okay, using stiffness method. But we cannot do that for flexibility method. In flexibility method, we can only calculate forces. Okay, we can only calculate forces, which is reaction forces, okay, including reaction at the support as well as member forces in truss. Okay, but we cannot we don't use flexibility method to calculate determinate structures, reaction in determinate structures. Whenever we cannot calculate reaction using equilibrium equation, means that determinate structures, we have to apply what we call as flexibility method. Okay, but in stiffness method, we can calculate both determinate and indeterminate structures. Okay, other advantages. Okay, okay, let's look at the next advantages. Okay, flexibility method. Method require different procedure for each two cases. Okay. Stiffness method yield displacement. Stiffness method yield displacement and force directly. Okay, this is the first one. This is the second one. Okay, in stiffness method, we will determine output number 1 is displacement. Output number 2 is forces. And we can get these two output directly using stiffness method. But we cannot do that using flexibility method. In flexibility method, we can only calculate reaction, and we cannot get displacement directly, okay, from flexibility method. When we want to calculate displacement, we have to apply another method called principle of virtual work in order to calculate displacement. Okay, for having flexibility method, and to calculate displacement, okay, when we solve for example indeterminate structures using flexibility method, we will get all the reactions, but we cannot calculate displacement. In order to calculate displacement, we have to apply another method, okay, called unit load method or principle of virtual work. And using principle of virtual work or this unit load method, we can only get one displacement, okay, at one time. Means that we cannot get all displacement using one using one time, okay, one time solution. Means that if we want to apply if we want to calculate displacement at A, we have to apply a unit value of virtual force at A, then we will calculate the displacement at A. And then when we want to calculate displacement at B, we have to apply another unit load method in order to calculate the displacement at B. If we want to calculate displacement at C, we have to apply a unit value, okay, at C in order to calculate displacement at C. So we have three set of solution, okay, in order to calculate the displacement using, okay, using flexibility method. That is not flexibility method. That is not flexibility method. In order to get displacement, we have to extend the analysis. We apply another method, which is actually the unit load method to calculate the displacement. Okay, but in stiffness method, the advantages of using stiffness method to analyze indeterminate structures. Number one, we can actually calculate both determinate and indeterminate structures using stiffness method. That is number one. Number two, we will get both displacement and forces directly. Okay, using stiffness method, we will determine the displacement and forces directly. And the first output we calculate from stiffness method is displacement, and number two is forces. Okay, whereas the flexibility method, the displacement are not obtained directly. Okay. Furthermore, it is generally much easier to formulate the necessary matrices for the computer operation using stiffness method. Actually, okay, in structural engineering, okay, to analyze huge structure where we have thousands element, thousand nodes, we actually have to use computer software. Okay, to use computer software. And the theory behind all structural engineering software is actually the stiffness method. Okay, the theoretical analysis or the theory behind structural engineering, okay, wait, I need to, okay, the theory behind all structural engineering software. The theory behind all structural engineering software is actually come from stiffness method. Okay, the procedure, okay, means that the procedure in analysis of structures using flexibility method, we will have several procedures. And all the procedures, step 1, step 2, step 3, step 4, okay, until we get the displacement and then we get forces, is actually the same process when we use a software to analyze the structure. For example, we will start with what? We will start with okay, we have to build the structure, what we have to apply step by step, what we gonna do in the theory will be the same actually in the software. Okay. Okay, so let's look at the term, okay, that you need to understand is in stiffness method. Okay, this is the first term that you need to understand. Okay, subdividing the structure into a series of finite discrete element. Okay, so what you need to understand is in stiffness method, what you need to do is you need to be able to divide the structure into element. Divide structure into element. Okay, for example like this. You are given the structure. You are given, for example, the truss. Okay, truss is the structure. Truss is the structure. So in order to analyze displacement and forces in truss, what we need to do is we must divide the structure into element. Divide structure into element. Okay, that is the term. We need to subdividing the structures into a series of finite discrete element. Okay, finite discrete element. And for each element, we are going to determine the stiffness matrices. The stiffness matrices. Okay, the stiffness matrices means that the K, because stiffness, the symbol is K, we will determine the stiffness in matrix form. We call it as stiffness matrix for element. Okay, in stiffness matrix, we will have stiffness matrix for element and stiffness matrix for structure. Okay, we don't have stiffness matrix for node. We only have stiffness matrix for element or member, and we have stiffness matrix for structures. Okay. uh, Endpoint, identifying endpoint as node. Okay, here we have to understand two terms, which is called as element and nodes. Element and nodes. So what is element? So element is member. Okay, what's the difference? Member, we call we call member using okay, this AB, BC. Okay, this is member. Okay, element. Okay, element is actually member, but we call element based on number. So we have element number 1. We have element number 2. Okay, we don't call element as element A, element B. We cannot call element as that. Okay, we have to call element using number. Okay, using number. Okay, means that element 1 is actually maybe member AB, and then element 2 we have member BC. Okay, because the stiffness matrix method is the theory behind software. Means that whenever we cannot analyze, for example, if we want to analyze simple structure like a continuous beam with 2 or 3 element, 3 members, of course we can calculate it manually. But when we have to design structure, to analyze structure, huge structure which has many elements and 1,000 elements and 1,000 nodes, of course we cannot calculate the displacement and forces directly. No, we cannot use ABC to represent thousand of element. That is why we have to use numbering. Okay, we have to use numbering. We may have structures with 1,000 nodes, 1,000 node or 1,000 element. So we cannot call as ABC because ABC has limitation. So in stiffness matrix, we have to use numbering to represent element and also to represent nodes. Okay, another thing is nodes is node. Okay, and node, what is node? Node is actually representing joint. Okay, not representing joint. Not representing joint. Okay, previously joint we call as joint A, we call it as joint B, we call it as joint C, but in stiffness matrix method, not we will use numbering as well. We will have node number 1, node number 2, node number 3, and so on. Okay, and the idea, another idea why we need to use numbering, okay, numbering to represent nodes and element because of the usage of this stiffness method in the software. Okay, in the software. Okay. Okay, refer back to this. Application of the stiffness method requires subdividing the structures into a series of finite discrete elements. Okay, we are going to analyze structure. Okay, how to analyze the structure? We have to have the stiffness matrix for element. Stiffness matrix for element means that we have to divide the structure into elements. So, for example, if we have truss, okay, if we have truss which has 3 members or 3 elements, we have to divide into element 1, element 2, element 3. Okay, divide the structure into element. Okay, for truss analysis, the finite elements are represented by each of the members that compose the truss, and the node represent joint. Okay, the node represent joint. The force displacement properties of each element are determined and then related to another using what we call as equilibrium. Of course, we have to maintain equilibrium. The structure must be in equilibrium to determine displacement and forces. But, okay, we don't use what we call taking moment at A, calculate. No, we don't use that. What we use is actually the formula, the matrix formula, normally given in appendix. Okay, in examination, the formula will be given, so you don't have to worry. But what you need to understand is the procedure. Okay, the procedure of using the formula, and the formula is actually for element, and how from element we will build. Okay, we will form the stiffness matrix for the structure. Okay, this relationship for entire structure are then grouped together, okay, to what is called as structure stiffness matrix. Okay, structure stiffness matrix. Okay, so okay, in stiffness matrix method, so what we need to understand is we need to divide structure. We need to divide into element. Structure you need to divide into element. And okay, analysis will be starting from, okay, from nodes. Okay, and analysis will be starting from nodes. Start from node. Okay, combine nodes to produce element. Combine element to produce structure. Combine element to produce structure. Okay, and one important thing is, in order to have one element, okay, we need to have 2 nodes. We need to have 2 nodes. Node number 1, node number 2. Okay, this is the nodes. This is the node, this is element. And nodes, for one element, we must have we must have what we call near node and far node. Okay, near node and far node means that element consists of two nodes. Element consists of two nodes. This is element. Okay, element number 1. So this is element. This is element. Element consists of two nodes, and combination of many element produce structure. Okay, means that in order to build the structure, the building, for example, using software, so we will start with one node. We will start with one node, and then we extend the nodes to another node, and then we will join two nodes as one element, and then we will continue to have many elements in the structure. And when finished, we will have the structure. Okay, nodes, it is actually like this, to understand more. Two nodes is one element. We cannot get one element consists of three nodes. Cannot. It always like this: two nodes, one element. One node cannot be element. One node. Is it element? Is it equal to one element? One element? No. One node is not one element. And then three node? Is it equal to one element? No. It must be this. To have one element, we must have two nodes. Two nodes means one element. Two nodes, one element. And many element, okay, many element becomes structure. Many element is the structure. Okay. Okay, this is the thing that you need to understand before we will start with the analysis of indeterminate structures, indeterminate thrust using stiffness method. So for the analysis, okay, for the analysis, I will be dividing into two parts. Part number 1, we are going to learn, okay, you are going to learn how to establish what we call as element stiffness matrices. This is number 1. And number 2, okay, number 2 is from this element stiffness matrices, we are going to establish what we call structure stiffness matrix. This is part 1. This is part 1. And for part 2, we will continue to apply stiffness equation or force displacement equation, and then we will calculate displacement, unknown displacement. We will calculate unknown displacement. And number 5, after we have determined unknown displacement, then only we can solve unknown reaction as well as internal forces. Okay, so this will be stage number 2 or part 2. Okay, so for the first week of analysis, we are going to focus more on part number 1, where I want students to understand how we are going to determine. We actually don't use the word determine, because determine means we will determine the single value, and what we will analyze in flexibility in stiffness method is actually the matrix. Okay, the matrix, the means that we will establish the stiffness, the element stiffness matrices, and we need to establish the structure stiffness matrix. So we will focus on this first part before we move to second part, because the first part is very very important. If we if student cannot determine the right structure stiffness matrix, of course it will be affected. Means that you will get the wrong output for the unknown displacement and reactions. Okay, make sure you can understand, okay, the term, the concept of stiffness method, and you must know how to use the formula given, okay, to determine or to establish stiffness matrix for element, and with stiffness matrix for element or element stiffness matrices. Okay, we you have to know how to get the structure stiffness matrix. So make sure every one of you will understand. Okay, we understand the first part first, then only we will move to the second part. And then this stiffness method is actually, if we compare to flexibility method, this will be this is more easier than previous, okay, previous topic. Okay, but this is new term, this is new thing, you don't you never use, okay, method like this before. So you need to start to understand, okay, understand the concept, understand the term, and inshallah you will be success in this topic. And from previous result, from previous, not only last semester, okay, this is the trend every semester, where students, okay, will score, okay, for this topic compared to flexibility method. But most importantly, you know, the first part, okay, of analysis, where you need to establish the right structure stiffness matrix. Okay, so I think that's all for this introduction. Okay, inshallah we will continue with next video. Okay, maybe I will explain more on the first part. Okay, the first part, before, okay, before we analyze the first part, of course what we need to understand is some more terms. Okay, the term like degree of freedom. Okay, degree of freedom is the term that you need to understand, and and you need to understand also, what we call as, okay, the diagram, the free body diagram, the sign convention for the stiffness matrix method. We will start with Truss analysis, and of course after that will be followed by beam analysis, and last one is frame analysis. And of course once you understand, of course we can apply the same procedure to analyze beam as well as frame. Okay, so that's all for this session. Inshallah, we will meet again in the next video. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.